Alright guys, right now you're not writing yet, you're just paying attention. We're reviewing a little bit. We've already learned how to multiply polynomials. So 2 terms by 2 terms. The binomial times the binomial. We should know how to do this. You may have learned it in other courses as well. A binomial times the binomial, you can use the strategies some people call FOIL, first outside, inside math. I don't use that term, but we do the same thing. We call it we're just using the distributive property. Everything in this parentheses is multiplied by everything in that parentheses. This is review for you. So when you're multiplying, number times number, variable times variable. So 25, b squared times b, can you tell me what b squared times b is? Perfect, b cubed. 5b squared times 1, same thing, times 1 is itself, so it's 5b squared. Now we're going to distribute the 6 to everything in the other parentheses. Number times number, 30, since we don't have another variable to multiply it, we just bring that along. 6 times 1 is 6. So we've done this before. This should look familiar. If we had like terms, we were like terms, same variables, the same exponent, we add it together at this point. But you'll notice, first term has an exponent of 3 on the variable, the second exponent of 2 on the variable, the third exponent of 1 on the variable, the fourth one no exponent. So those are the like terms, so that would be the product of those 2 binomials. So far, so good? Alright, so this is not what we're doing today. Today, they're going to give us the product, and we have to give them the factors for the multiplication problem. Make sense? Okay. So you'll notice, sometimes when we multiply a binomial times a binomial, we got a trinomial, because we can combine those middle terms, right? In this case, and for today's lesson, our answers are going to be mostly a binomial times a binomial. They're going to give us 4 terms, like our product here, and they're going to ask us to give them the 2 factors. So we're going to have steps, but I promise if you will follow along the steps, it sounds really confusing right now, but it's super easy if you follow the steps. Alright, so, real quick, don't have to write anything yet. I'm going to do this real quick. B12p cubed plus 21p squared. You're not writing anything right now, you're just paying attention. Minus 49. This is all stuff that you've done, right? We multiplied these 2 binomials, we got these first 4 terms that can't be combined. So how many terms are in the product? Remember, the product is the answer when you multiply something. It's 4 terms. 4 terms are what we're going to be factoring. So, what is the greatest common factor of the first term of the product? So let's look here. The first 2 terms. Here and here. What's the greatest common factor of those 2 terms? So remember, greatest common factor could be a number, a variable, or a number and a variable, right? So is there a greatest common factor in the numbers? 21 not a greatest common factor. 12 and 21 is there. What's the greatest common factor of 12 and 21? 3. That's right. What about for the variable part? P cubed and p squared. Well, they both have p, but don't they both have p squared as well? Yes, we get the most p's that they both have. This one has 3 p's. You're not writing, paying attention. This one has 2 p's. They both have 2 p's, so p squared is the greatest common factor. Make sense? Now what's the greatest common factor then of the last 2 terms? What's the greatest common factor of 28 and 49? 7. And there's a variable here but not there, so 7 is the greatest common factor. What if we add these together? So this is what do you notice about the sum? What do you notice about this? Isn't that the first factor? Ah. So if we group them, get the greatest common factor of both groups, we get the first factor, the first part of our answer. All right? What if we divide the greatest common factor from the first term, two terms? So the greatest common factor of the first two terms is 3p squared, right? So if we take 3p squared, 12p, it's easier. If we take 12p cubed minus 21p squared and we divide it by that greatest common factor, let's see what we get. So 12p cubed minus 21p squared, and we're not writing anything, we're just paying attention. Greatest common factor here, 3p squared divided by 3p squared. So let's see. What's 12 divided by 3? What's p cubed divided by p squared? P, that's right. So some people are confused in first period. I'll remind you. P cubed is 3p. P squared is 2p. Those cancel, right? So that's going to leave you with 1p. Okay, and that's a minus. What's 21 divided by 3? What's p squared divided by p squared? 1, right? So guess what? What does this look like? The second factor. So we can use that simple greatest common factor concept that we've already learned about and used a fair amount to factor a four-term polynomial. Now, they can't all be factored, but for our purposes, all of yours will be factorable. All right, so you don't have to worry about that. No tricks. We are going to go ahead and start filling in our notes. Do a little bit quickly because we had lost some time for the fire drill. Maybe as big as I can. All right, so remember that not all polynomials can be factored. This is your first thing you're filling in right here. Not all polynomials can be factored. We're going to always pull out the greatest common factor first, if there is one. So if possible, we pull out that greatest common factor first, and that greatest common factor would have to be part of our answer. Normally, it's going to be a binomial times a binomial today, but if you pull a common factor out first, you'll have that greatest common factor and then two binomials. Okay? It's helpful to put the polynomial in standard form, but sometimes you may have to rearrange it. For our purposes today, though, standard form is best. You won't have to rearrange them. Now, what does it mean to be factored completely? You do need to know that. To be factored completely, there can be no common factors greater than 1. So now the next section, we are going to use an example and write some steps. And you can use these steps for all of your problems today, all right? So when you're doing your homework, you're going to want to have your steps out. All right, the very first thing we're going to do is we're going to group our four terms into two expressions. Now, they're not two factors. They're not two factors. We're just putting the parentheses around the plus sign here. Now, on your homework, you're going to be able to just do it like that. All right, but for your notes, I want you to write everything you have here. And I'll do some examples where you don't have to write it out like that. So the next thing we're going to do, we're going to pull out the greatest common factor of each group. So what is the greatest common factor of the first group? Well, what's the greatest common factor of 8 and 12? 4. What's the greatest common factor of w cubed and w squared? Perfect. So that is the greatest common factor of the first group. What's the greatest common factor of the second group? Yes, we're writing this down. What's the greatest common factor of the second group here? 5, that's right. So this is if if the first term is negative, we factor out a negative greatest common factor. We don't have that in this example. We will have an example. I'll show you that. If the group doesn't have a greatest common factor, the greatest common factor is 1. We will have one like that. I'll show you. Okay. So for this problem, now we're down to the step we're going to use here. The sum of these two greatest common factors is one of our factors. So the sum, that just means we're adding them. If this were a negative, we'd subtract them. Right? That's positive. So we're going to add or subtract depending on what the sign of that second greatest common factor is. So we're just adding the two greatest common factors. That's our first part of our answer. You follow along with them? We're going to divide the first two terms by the greatest common factor of that group. So the greatest common factor of the first group is going to be the first GCF, right? So we're going to take that first group, 8w cubed plus 12w squared, and we're going to divide it by the greatest common factor. Let me know if that makes sense or doesn't. Let me know if that doesn't make sense to you. I'll try to explain it a different way. Eight divided by 4 is 2. W cubed divided by w squared is just w. 12 divided by 4 is 3, positive. W squared divided by w squared. What's w squared divided by w squared? 1. So this would be 3 times 1, which is just 3. So guess what? That is our second factor. That's it. We've really done it. We're just going to write it in answer form. So your final answer, I can't remember which part, but whatever part goes in the blank, fill that in. And so the answer to this problem would be the two factors written like the multiplication problem. 4w squared plus 5 times 2w plus 3. I'm going to show you how to check it. I'm not going to require you to check it. So if we check, if you want to check on a test, if you have enough time, you're going to go back and check. You just multiply. Let's see if we get what we started with. 4w squared times 2w squared is 8w cubed. You're writing what I'm writing. 4w squared times 3 is 12w squared. 5 times 2w is 10w. And 5 times 3 is 15. Is that the four-term polynomial we started with? It is. So now we know our answer is correct. Remember, this was our answer. So we're going to do some examples together. I'm sorry, I know I'm moving a little bit quickly because we lost so much time with the fire drill. But this is recorded, so you can always go back and watch it again if you need no help. All right, caught up with me? All right, so we are going to start with this example in the back. The very first thing we do is we look to see if there's a greatest common factor, either a number or a variable. We know there's not a variable common factor because there's not a variable in all four terms. Is there a numerical factor? Well, I'm looking at 21 because that's the only odd number. Factors of 21 are 21 and 3 and 7. Well, 7 is a factor, 56 not a factor, so we don't have a factor that comes out of everything, right? 3 comes out of this one and this one. 2 will come out of these 3. 7 will come out of these 2. We don't have a number that comes out of all of them, so we can skip that step. We don't pull out a greatest common factor. Now we're going to go to our first step. What's your first step say? Look at your steps real quick. First step says, group them? Is that what it says? Okay, and so I'm not going to make you rewrite. Now you can actually use that problem and work involved here, but what work I'm asking you to show, you have to show or you won't get credit. Is there another way to factor these four terms that I'm teaching you? There is. And you can use any way that is mathematically correct, as long as you don't skip steps. I implore you not to get on an app and try to copy it. You won't have all the steps, and you won't have any help. If you'll follow these steps we're about to do, you'll see it's pretty easy. It's always very straightforward. What's the greatest? So the second step says to find the greatest common factor of each group. What's the greatest common factor of the first group? 2, all right. Is there a greatest common factor of the variables? B squared, that's right. What's the greatest common factor of the second group? And since this one's positive, that's going to be a positive 7. Guess what? We wrote them as a sum, and that's our first factor. We're halfway done. Okay? What's step 4 say to do? Very good. So we're going to divide the first group by the greatest common factor of that group. What's the greatest common factor of the first group? It's the first here, right? So we're going to divide that. We're just going to write it as a fraction here and divide them. This is going to be, what's 6 divided by 2? What's b cubed divided by b squared? If you forget, remember b squared would be 3b. I'm sorry, b cubed would be 3b. B squared would be 2b's, and we can cancel everything. So what do we have left? Yep, 1b. So b. This is a minus, so that's a minus. What's 16 divided by 2? 8. And b squared divided by b squared is 1, so those should simplify out. Guess what? That's it. You're done. It seems harder than that, right? But that's it. We have a bunch of steps, but when you're actually doing the problem, you don't have to write every step out. We can kind of do it on that problem like that. Does that make sense, Keisha? Akira? Does that make sense? Does that make sense, Peyton? Danielle, does that make sense? Danielle? Okay. All right, so sometimes the last terms are not going to have a greatest common factor. What do we do then? We put it in our notes. We said if there's not a greatest common factor, we're going to use 1. But let's go ahead and do our steps. Is there something that will come out of all 4 terms, a number or a variable? 5 will come out of these 3. Will 5 come out of this one? No. So if there's not a numerical common factor, is there a greatest common factor of the variable? Can't be, because this one doesn't have a variable, right? So what's step 1 say to do? Group into 2 expressions. That's right, fine. What's step 2 say to do? Pull out a GCF from each term. Okay, so what's the GCF of the first group? 5. Is there a variable greatest common factor? J squared. Very good. What's the greatest common factor of the second group? There's not one, so that's the purpose of this example. If there's not one, you put a 1. All right, and that, the sum of those is our first factor. What does step 3 say to do? Did we already do that one? Yep, so one said the sum of the 2 GCFs is a binomial. Remember, this is the greatest common factor of the first term, a group. This is the greatest common factor of the second group. Now, what does step 4 say to do, Annabelle? Okay, so we're going to divide the first 2 terms. What's the GCF of this group, Naya? 5 what? Right, so remember, this is the greatest common factor of the first group. This is the greatest common factor of the second group. So if we're Dividing the first group by its greatest common factor is always that first one. All right. So this is going to be our second factor. What's 25 divided by 5? What's j cubed divided by j squared? Yeah. What's 15 divided by 5? Remember those positives, so plus 3. And that will be times j squared divided by j squared. But what's j squared divided by j squared? 1. So 1. Right. So guess what? That's your answer. If you multiply this times this, you get this. What work do you have to show me? You have to show me the groups. And you have to show me that you divided the first group. Right? That's really it. Any questions? Jaden, you good? All right. So this is an example where we do need to pull out a greatest common factor first. What is the greatest common factor of all four terms? What? I'll tell you, it's not a variable because the last term doesn't have a variable. It could be, and sometimes will be, a variable. It is 3. 3 is a factor of 21, 84, 15, and 60. The trick is if you add 2 and 1 together, that's 3. 3 is divisible by 3. You add 8 and 4 together, that's 12. 12 is divisible by 3, so it is. Add 1 and 5 together, that's 6. That's divisible by 3. 6 plus 0 is 6. It's divisible by 3. So if the sum of the digits is divisible by 3, then you know those numbers are divisible by 3. Okay, so that's a little trick to help you figure that out. So we know that the greatest common factor here is 3. So 3 has to be part of our answer. And I'm going to go all the way down here. Actually, I'm not going to go there. I think I'm going to go there. All right. So 3 times 7k cubed times 28k squared, 3 times 5k, and 3 times negative 20. So I have to rewrite this expression without the greatest common factor. So this is a 4-term polynomial, and we should be able to factor it. But when we pull out a greatest common factor, that is going to be part of our answer, but we're not going to mess with that anymore for right now. So our final answer is going to be 3, and I would encourage you, when you have a greatest common factor like this, go ahead and write it in your answer blank, because kids forget to add this to their answer. If you forget the 3, the 2 binomials, when you multiply them together, they won't equal that beginning expression. Okay? So now, though, we can ignore that 3. We put it in our answer blank. Now, really, this is the part we're working with, right? So I'm going to rewrite it here so it won't be confusing. 7k cubed minus 28k squared. You're ready when I'm ready. Plus 5k minus 20. Now, we're going to start with our steps. What's step 1 say again, Kendall? Yep, we're going to put it into 2 groups. The first 2 terms, second 2 terms. What's the second step say to you, Corey? Second step? Flip the paper over and look at number 2. What's it say? Of what? Pull out GPA. No, of those groups. Read the words to me. Does it number 2, it says, yeah, pull out a GCF of each group. That's what you should have in that blank. So we're looking at the first group. What is the greatest common factor of 7k cubed and 28k sum of those is our first factor. So we're halfway there. So how do we find our last factor? So what's the next step say? Can you see what step 4 says? Okay, the first two terms would be this group. What is the greatest common factor of that group, Fatima? What's the greatest common factor? What are we dividing these two by? 7 what? Yes, so remember, this is the greatest common factor of the first group. This is the greatest common factor of the second group. So we're dividing it by 7k squared. 7k squared. 7 divided by 7 is 1. K cubed divided by q squared is what? K cubed divided by q squared is what? A. Now this is a minus. 28 divided by 7 is 4. K squared divided by q squared simplifies 1. So that is your final answer. We have one more.